Hi and welcome to Sketching Quadratics Part 2. And in this video we're going to spend a bit of time talking specifically about turning points and how we can find turning points. Now you've spoken about turning points before and you've probably explored them a fair bit. But in this video we're going to talk about how you can find turning points using three different methods. And I'm actually going to do it using a standard function there, which you can see y equals negative x squared minus 8x, and completing it using the three methods I've listed, by completing the square, by symmetry, and by the rule. Now this is going to be a bit of a frustrating order because you'll see that it pretty much gets simpler as we go along. But there's some important ideas here. So let's start with completing the square. The first thing I want to do is remind you that the aim of completing the square is to get our form x plus a squared, so that we have a singular x. Now we know that if we expand this, we get x squared plus 2ax plus a squared. And if you're unsure about that, try it, expand it. You notice that in our second, on our right hand side, we have an x squared and we have an x. And we want to simplify this, and there's lots of good reasons to do this. You might explore those a little bit later, or you may have explored those already. But for now, I'm just going to say that the aim is to simplify it down to a function that has a singular x in it, rather than that double x. So, let's go through and complete the square. First of all, y is equal to negative x squared plus 8x. Now, if you're completing the square and you're not given x squared as the leading term, but say you've got 2x squared or 5x squared, or in this case you've got negative x squared, the first thing you want to do is take out the negative. Now this doesn't have to happen, but it makes life a bit easier in my opinion, so it's a process that I follow. And you get to make that choice. There's lots of different ways you can go about it, and you may have seen different ways. It's really good to explore those different ways and then go about it the way that suits you. So I've taken that negative out as a common factor. Now I'm going to recognize that this negative 8 is basically my 2a value. So I've got negative 8 instead of negative 2a. And that tells me that my a is going to have to equal 4. And so I'm going to factorize this down now to get my a to, it's actually going to equal negative 4 because that negative will carry with it. I'm going to factorize that down with that a. Now with this in mind, I end up with negative x squared, then minus 8x holds, but I'll now get a minus 4 squared, so plus minus 4 squared, and then I get an additional term at the end, minus 4 squared. Now the first thing I've done is I've recognized that I needed this plus a squared at the end to make it into this form, which is my aim. The second thing I've done though is I've subtracted the thing that I added, and that way I haven't actually changed my function. So if I'm going to just invent and add this additional negative 4 squared, then I need to also subtract that negative 4 squared to even out the function. Now I'm going to simplify this. I get negative x squared minus 8x plus 16 minus 16. So I've probably done an extra line of work and you don't really need. And I'm going to take that last 16 outside the brackets, minus x squared plus minus x squared minus 8x plus 16. And then negative of a negative makes plus 16 on the outside. And now you can see that I'm in the form here, which means that I can take it to that form there. And so it gives me negative x minus 4 squared plus 16. And if you're unsure about that process, then might I suggest that you take some time to have a look back through. Okay, so now I'm going to use this to determine my turning point. So remember, my turning point has this value is my h, and this value is my k. Remember, it's given to you in the form negative h. So this actually tells me that my turning point is 4, 16. That 4, the negative doesn't carry with it, it's the opposite sign, but the 16 holds the same sign. My turning point is 4, 16. And so you'll notice up here that this point here is 4, 16. And you might also notice that I've made a slight error here. That should actually be 12. Okay, so that's the first method, completing the square. If you're unsure about completing a square, go back and practice it. I strongly urge you to go back and make sure you understand it. It's the higher end, the harder thing that you do in quadratics, but it's a really important rule to understand. The second method is symmetry. So if we go down to symmetry now, let's rub this off and pretend we don't know what the turning point is. So if you're using symmetry and you know 2 points that are on the same horizontal line in the quadratic, you can actually use that to find your turning point. So I'm going to do method number 2 over here. So the first thing I'm going to do is recognize that I know that the point 0 and the point 8 are 2 points on my quadratic, there, and they exist on the same horizontal line, which is the x-axis. Now it's really important here that I recognize it doesn't have to be your x-intercepts. So for example, if I knew the other point on this horizontal line, I could also use that, and that would be fine. But I'm going to apply symmetry now, because I know a quadratic is symmetrical. So therefore my turning point x value, so you know my turning point is a coordinate, but the x value of my turning point is actually symmetrically between those 2 points that are my x-intercepts in this case. And to find the average of those 2 points, I do 0 plus 8 over 2, and that's equal to 4. So my turning point x value is 4, and my turning point y value comes from my original function. And I'm just going to scoot sideways to get this in. It comes from this negative x squared plus 8x, but in this case I put in my 4, negative 4 squared plus 8 times 4, and that's equal to 16. And so therefore my turning point in total is 4, 16. As required, same answer as earlier. Lastly, we can use what's called the rule. And the rule is actually, I'll scoot down a little bit for this and rewrite down our function. So our function is y is equal to negative x squared plus 8x. And you'll also recall this function, x equals this formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you'll recall that this little bit inside here is called the discriminant, and we've talked about that earlier. Now the discriminant is the bit that you add or subtract on to find your x-intercepts. You add it on for one of the x-intercepts, you subtract it for the other x-intercept. The bit in the middle is here. That thing represents the middle, and then you add or you subtract your discriminant on. So actually, the turning point x value is equal to negative b over 2a. So in this case I have a is equal to negative 1 and b is equal to 8, and so my turning point x value is equal to negative 8 over negative 2, which of course is equal to 4. As required, as we got earlier, my turning point y value is equal to, I'll put it straight back into the function, negative 4 squared plus 8 times 4, and that gives me 16, giving me a turning point of 4, 16. So of course, you can use any of these forms. You can use the completing the square, or symmetry, or the rule. And it really depends on the format you're given as to which one's easier. You'll never quite know, but you make a choice. And if you learn all those rules, then it's really good because that means you have that choice. All the best.